Alright, what we're going to be talking about next is basically symmetry. Okay, symmetry. We're going to look a little bit about what symmetry means in terms of our graphs. But this is basically for an equation. So symmetry for an equation, what we're going to do is we're going to take our function and we're going to do the same thing every single time. So we're going to take the function and we're going to plug in negative x into our function. Alright, if you plug in negative x into your function and you get the same thing as the original, then what we're going to say is, if this occurs, our function is even and is symmetric about the y-axis. Okay. We also have this option where when you plug in negative x, you get the opposite of your original function. Then your function is odd and it's symmetric about the origin. So symmetry is very important for us because it's going to allow us to graph more effectively later on, because with symmetry, if you find one point, there should be some other point along your graph that corresponds to that point also. So kind of keep that in mind, but if you notice the test is the same, what we're going to do is we're going to plug negative x into our function. If it's the same as the original, it's even, symmetric about the y-axis. If it's the opposite, it's odd, symmetric about the origin. So let's look at a couple examples. Here we go, f of x. So again, what we're going to do to test for symmetry, whoops, might help if I write instead of highlight. We're going to plug in negative x, and that's going to give us negative x cubed, and then minus 6 times negative x. Well, after you plug in negative x, you're going to simplify it. Well, negative x times negative x times negative x is negative x cubed, and negative 6 times negative x is a positive 6x. Now what we're going to do is we're going to compare our answer, what we got when we simplified that, to the original. And as you can see, if you took this right here and you distributed a negative, or took the opposite of the polynomial, that you would get this. So therefore our function is said to be odd. Since it's the opposite of the original, we plug in negative x. This is an odd function. And graphically what this means is this is going to be symmetric about the origin. Looking at the next example over here, what we're going to do is we're going to plug in negative x into our function. So again, you can see the test is the same. Negative x raised to the fourth minus 2 times negative x squared. Alright, well, when you raise negative x to the fourth, it's negative x times negative x times negative x times negative x, which will give you a positive x to the fourth. And when you square negative x, you get x squared times negative 2 is negative 2x squared. So as you can see, when we compare the simplified form of this expression or to this one, you can see that they are the same. So anytime it's the same, you're going to say that your function is even. So this is an even function. And what this tells us, our graph is symmetric about the y-axis. All right, there you go. We're going to look at one more example here in the next one.